Quarter 4, Module 5, entitled Identifying the Appropriate Rejection Region for a Given Level of Significance. Critical value, significance level, and rejection region. In hypothesis testing, a critical value is a point on the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis. Critical values for a test of hypothesis depends upon the test statistic, which is specific to the type of test and significance level denoted by alpha, which defines the sensitivity of the test. A value of alpha which is equivalent to 0.05 implies that the null hypothesis is rejected 5% of the time when it is in fact true. In practice, the common values of alpha are 0.1, 0.05, and 0.01. So, critical value katuganing boundary sa atoang rejection region o non-rejection region. Magdepende na siya sa kung unsa nga type of test o unsay level of significance nimo. Next, critical value of Z distribution. A critical value of Z, or also known as Z-score, is used when the sampling distribution is normal or close to normal. Z-scores are used when the population standard deviation is known or when you have larger sample sizes. While the Z-score can also be used to calculate probability for unknown standard deviation and small samples, many statisticians prefer using the t-distribution to calculate these probabilities. So bottom line, pag once standard deviation is known or large ang sample size, meaning sample size is greater than or equal to 30, we will use the Z-score. Ang Z-score can also be used to find or to calculate probability na unknown ang ato ang standard deviation tapos sample size ang gamay, pwede na siya Z-score, pero many statistician pag unknown tapos small ang sample size, t-distribution gid ang ginagamit. So these are the critical values of Z-score. Actually, na-present na nato ni sa kuan. Left tail test. When you say left tail test, kabalo naman ta mo determine if the alternative hypothesis contains less than inequality symbol, nga less than, the hypothesis is left-tailed. Right-tailed pod, pag once ang imong alternative hypothesis contains the greater than inequality symbol, it is a right-tailed test. Two-tailed test siya pag once ang imong hypothesis alternative hypothesis contains the not equal to nga symbol, kani nga symbol. So the hypothesis test is a two-tailed test. In a two-tailed test, each tail has an area of 1/2 your alpha. So duha naman, so gitunga nimo imong alpha. So examples ta. Find the critical values in each case. Assume the normal distribution applies. Left tail test with alpha 0.01 and Z is yun sa pagkabalo nga Z is equivalent to negative 2.33. Based sa ato ang given nga left tail siya tapos alpha na to. So kay Z man siya dito ta sa Z table. Left tail nara and then ang alpha na to is 0.01. So left tail kani tapos 0.01 nara, so ang intersection nila is negative 2.33. Basically kung left tail negative na, right tail positive na. So gigana pagkabalo. What about two-tailed test tapos alpha is 0.05. So adto ka kay two-tailed nara tapos alpha na to is 0.05. So ang intersection nila positive and negative 1.96. So positive and negative pag two-tailed. Right-tailed with alpha is 0.025. So adto ka kay right-tailed tapos tanaw ka sa taas 0.025. That's positive 1.96. So basically pag right-tailed positive po siya. Yun nga to. Next, critical value for t-distribution. The T-distribution table values are critical values of the T-distribution. The column header, kabalo naman tayo actually. Kumana tayo nag-discuss ani. To find the critical values, kailangan na to i-identify ang level of significance and determine the or identify the degree of freedom using the formula df equals to n minus 1. Then, find the critical value using the T-distribution in the row. So, left tail siya, alpha nimo, tanaw ka sa one tail. Right tail siya, one tail gihapon. Tapos same, negative, positive. Kung two-tailed, dito ka sa two tails. So, example ta. Now, by the way, before ta mag-example, this is the table. Critical value table for T-distribution. So, diri ta magtanaw kung one-tailed, diri ta magtanaw kung two-tailed, diri ang degrees of freedom. So, mao ni ang mga critical values niya. Yun. So, example, find the critical value of the left tail test with alpha 0.05 and n is 21. Yun sa pagka-come up si negative 1.725. So, again, tanaw nimo si alpha na 0.025 and n nimo is 21. So, since n is 21, therefore 20 atong degree of freedom. So, adto ta kay 20. Nano ganin 20? Because n minus 1 ang degree of freedom. So, adto ta kay 20. Nara si 20, tapos, sa to? Left-tailed ga 0.05. 20, nara. Tapos left-tailed, nara. Sa ha? Left-tailed. So, left-tailed meaning one tail ra siya. 0.05. Tapos 20 man. Ato ka kay 20. 1.725. Tapos negative again because left-tailed siya. Next, what about right-tailed nga 0.01, tapos n nimo is 17. So, n na to is 17, therefore, degree of freedom is 16. So, right-tailed man siya, so one-tail ta. One-tail ta kay 0.01, tapos 16 ang df. So, ito ta sa table. One-tail, 16. Dari. One-tail, 0.01. Nara. 0.01 sa one tail, tapos ato ta kay 16. 2.583. And positive because right-tailed man siya. Next, two-tailed. 0.05. Tapos n is 26. So df na to is 25. Two-tailed, 0.05, 25. So ato ta sa table. Two-tailed, 0.05. Kara, and then 25. 2.060. Tapos kay two-tailed man, positive and negative ta. So, ngana papangitag critical value for T-distribution. So, let's discuss about critical regions and critical and rejection regions. Critical region is also known as rejection regions. This one describes the entire area of values that indicates you have to reject the null hypothesis. In other words, the critical region is the area encompassed by the values not included in the acceptance region. It is the area of the tails of the distribution. The tails of the test are the values outside the critical values. In other words, the tails are the ends of the distribution and they begin at the greatest or least value in the alternative hypothesis. So, critical region or the rejection region. Usually, actually, naana sa left, right, or sa both tails niya. So, rejection region, if population variance is known. So, to determine critical region for normal distribution, we use the table for standard normal distribution. If the levels of significance alpha is 0.10, then for a one-tailed test, the critical region is below z equals to negative 1.8 or above z equals to 1.28. So pag once one-tailed siya, it's either below your negative or above your positive nga z-score. Pero kung two-tailed siya, kailangan nimo i-divide 2 ang imong alpha and ang critical region pud ana is below the negative and above the positive. Again, kung one tail, depende. It's either below your negative z or above your positive z. Pero kung two-tailed, dapat naa siya ang critical regions nimo duha ka buok. Below your negative z and above your positive z. So, ingani ang pag-determine. If the absolute value of the calculated statistics have a value equal to or greater than the critical value, then the null hypothesis H sub O should be rejected. And the alternative hypothesis H sub A is assumed to be supported. So, kung mag-base ka sa sketch, dali lang man kung nakay graph. Pero kung dili necessary mag-graph, dito ka sa value nimo. Absolute value of your calculated statistics has equal value or greater than. Kung equal or greater than, ang null hypothesis should be rejected. So, kadto lang ang bantayanan ninyo. Kung ang absolute value sa imong statistic nga na-solve equal or greater than, reject the null hypothesis. So, these are the hypothesis test and their tails. Kung left-tailed test, naara sa left ang imong rejection region. Kung right-tailed test, naara pod sa right imong rejection region. Kung two-tailed test, nasa both tails, left and right. So, this time, let's have an example. Determine the critical values of the appropriate rejection region, then sketch the sampling distribution. So, given right-tailed test where theta is known, sigma is known, your alpha is 0.05 and n is 34. So, basically, we have a table of critical values. So, ang first kailangan natin mahibalan, unsa nga test, z-test ba siya or t-test. So, para makabalo ta unsa nga table ato ang gamiton. So, based sa given, sigma is known. So, population standard deviation is known. So, kung population standard deviation is known, automatic z-test ta. Labi na nga, ang sample size na to is greater than 30. Okay, so therefore z-test ta. So, kani atong gamiton. So, based dere, nita tag alpha, right-tailed man, ato kakang right-tailed, and under sa right-tailed, under sa 0.05. So, 1.645. So, 1.645, so, sketch na lang na nimo. Draw your curve, tapos right-tailed man siya, so sa right ka. Then, positive, because again, right-tailed. So, dere imong rejection region, nasa right. Ang z nimo is 1.645, so naana, dol-dol gamay kay 2. So 1.645. So nga na pag-determine sa rejection region. Another example, two-tailed test where your population standard deviation is unknown. Your alpha is 0.05 and n nimo is 10. Since your sigma is unknown, at the same time sample size is less than 30, t-test ta ani. Mao ra man din tong bantayanan, di ba? Basta unknown and then less than 30, t-test ta. So dito ta sa table sa t-test. Sa pagpangitag t-test, kailangan nato si degree of freedom. Degree of freedom nato since n is 10, so degree of freedom nato is 9. So 9, 0.05, two-tailed. So mo tay bantayanan. 9, 0.05 na two-tailed. Darita magtanaw sa two-tailed. 0.05 tapos 9. So 2.262. Since two-tailed po siya, sa left and right ta magbutang. Ang isa positive 2.262, so unahan gamay sa 2. Ang isa negative 2.262. Unahan pud gamay sa negative 2. So mao ni imo mga rejection region. So that's how to determine. Another example, left tail test where theta is known and alpha is 0.01 and n is 40. So again, alpha is known. So klaro na nga z-test ta. Labi na nga n na to is 30. So kani atong gamiton nga table. So pagpangita ani adto lang ka kay left tail test kay given nga left tail tapos 0.01. So negative 2.33. So ang imong graph nasa negative side. Negative 2.32. Actually kani nga value, ang kani nga value diri is naka-round off na. So basically negative 2.326 is negative 2.33. So same lang. So unahan siya gamay kang negative 2. Left siya part. So left tail. Again negative. Okay. Number 4. A survey reports a customer in the drive-thru lane of one fast food chain spends 8 minutes to wait for her or his order. A sample of 24 customers at the drive-thru lane showed mean of 7.5 minutes with a standard deviation of 3.2 minutes. Is the waiting time at the drive-thru lane less than that of the survey made? Use 0.05 significance level. So basically, ang ato ang rule lang ani for this time is to determine the rejection region. So again, pangitao na to ang mga given. Sample of 24, mo na tong n. Sample of 24 and then kaning 7.5, actually, sample mean ni siya. Kay sa sample man na. So this is our x bar. Standard deviation. This is our sigma. Ano, sorry. This is not sigma because sa sample man eh. So, dili ni siya sigma. S ni siya. Nanuman because a sample of 24. So, sa sample ni siya nga standard deviation. Tapos, is the waiting time through lane is less than. So, less than. So, meaning left tail test ni. Kanatay, sigma nga, alpha nga 0.05. So, mga na itong mga given. From that, let's determine kung mag-z-test ta or mag-t-test. So, based sa given, wala tay sigma. Wala tay sigma because ang given lang is sample standard deviation. Unknown atong population standard deviation. And ang atong sample size is less than 30. N na to is less than 30. So from that, we can say that we need to use the t-test. So mag-t-test ta. So atong gamiton is kani. T-value atong gagamiton. So mao ni atong hypothesis equal tapos less than siya. So therefore left tail test unknown and then our alpha is 0.05. N na to is 24. So kung detailed ta, kailangan na to ang degree of freedom. So ang degree of freedom na to is 23. With alpha is 0.05. Tapos, one-tailed ta, kay left-tailed lang man. Sige. Let's use the so add to ta og one-tailed tapos 0.05 then 23. One-tailed 0.05 tapos 23. Kana dapat. I think mao nitong example nga mali ang problem. Mali ang given. Ang answer nila is kani. Less than or equal to negative 2.069. Naara ilang gihatag. So, one-tailed man ta nga 0.05. So, dili. Dire dapat. So, alpha 1 tail, 0.05, 1.74 dapat. So, dapat negative 1.714. Negative 1.714 dapat na. And then, dapat dire, naara na dire. So, appeal dire ang shaded region. dapat T must be negative 1.714. Mo ng critical value na to. Okay, again, based sa ito ang kuan, left tail na to 23 tapos 0.05 na one-tailed. Naramang one-tailed. Narang one-tailed, so 0.05 tapos 23. So 1.714 dapat. So take note of that na lang. So last example, we have here a banana company claims that the weight mean of their banana is 150 grams with a standard deviation of 18 grams. Data generated from a sample of 49 bananas randomly selected indicated that a mean weight of 153.5 grams per banana. Is there sufficient evidence to reject the company's claim? Use alpha 0.05. So from that, let's first determine mga given. Banana company claims that the mean weight of their banana is 150 grams. So kani, maning claim sa banana company. So actually, this can be your population standard deviation. This is your mu. Population mean. While ang standard deviation is 18 grams, this is our sigma. The data gathered from a sample of 49, so this is our sample size. Randomly selected indicated that the mean weight is kani, mo na ning X bar. Sample naman eh. Kato ganina population. Then, ang question is there sufficient evidence? Tapos ang alpha na to is 0.05. So, ang first thing to determine is kung naabay unsa nga test. So, since given atong sigma, tapos population sample size nato is greater than 30, so this means mag-z-test ta. So, ang atong hypothesis equal to 150, nara. Ito ta sa mu, not equal. Kay wala man siya diri, is there a sufficient evidence to reject the company's claim lang man? Wala man siya ningon less than, greater than. So, not equal, so therefore, mag two-tailed test ta. Kay not equal man eh. Then, given si sigma and alpha, and nato is 49, so therefore, mag z-test ta. So, using the table para sa z-test, two-tailed nga 0.05. Mga naibantayan. So, two-tailed nga 0.05. So, positive and negative 1.96. So, positive 1.96, duol kaayo kay 2, naara. Negative 1.96, duol pud kay 2. So, since two-tailed, left and right siya. So, the rejection region is less than or equal to negative 1.96 or greater than 1.96. That's all for our topic. Thank you and see you next session.